We've all been there. You're deep into a complex coding session, juggling a dozen files, when suddenly you hit a wall. Your AI tells you that you've reached your usage limit. The reason this happens is simple but incredibly punishing. By default, large language models have absolute amnesia. They don't actually remember anything from one message to the next. This bar chart shows data load escalating with every message. By your 16th prompt, the AI must completely reprocess 15 previous turns. This geometric data explosion requires massive compute power, making deep workflows expensive and almost impossible to sustain. Each new message carries the full financial weight of the conversation's entire history, creating a tax that grows heavier with every single turn. To solve this massive inefficiency, engineers developed an under-the-hood mechanism called prompt caching. When the system successfully holds your previous context in a temporary memory cache, the token cost to retrieve that information drops by 90%. For heavy users, that single mechanism effortlessly saves hundreds of millions of tokens in 1 week. But here's the catch. While this caching happens automatically in the background, your normal daily habits are likely breaking it. When the cache breaks, the system quietly reverts to charging you full price without telling you. Mastering how this invisible memory actually works is the deciding factor between an uninterrupted workflow and constantly running out of your daily limits. This diagram shows how the AI views your prompt, not as a simple chat box, but a vertical, 3-tiered stack of information. At the foundation, you have the base system instructions and tool definitions. Right above that is the project layer. This holds your custom rules, reference documents, and attached files. Finally, resting at the top is the active conversation layer, containing the immediate back-and-forth messages. When you open a fresh session and send your first message, the system has to write this entire 3-tier stack into memory. This is called a cache create, and it incurs a 100% processing token cost. On your next turn, as long as the memory stays intact, the AI performs a cache read. It pulls those foundational bottom layers from the saved memory, bringing the processing cost for that massive chunk of data down to just 10%. True efficiency relies entirely on keeping those heavy foundational layers perfectly intact, forcing the AI to only process the tiny top sliver of new conversation. That efficiency is incredibly fragile, however, because it is strictly governed by a countdown clock known as time to live. For standard Pro subscribers and Claude Code users, that memory shelf life is exactly 1 hour. But if you're building with the API or running sub-agents, that window dramatically shrinks to just 5 minutes. Watch what happens to the memory stack here. If you step away for lunch and that digital timer hits 0, the entire cache is instantly wiped completely blank. The exact same collapse happens if you edit the core system instructions mid-session, or if you toggled between different intelligence models, like switching from Opus to Sonnet for a specific task. Taking a break, switching to a faster model, feels like a standard habit, but underneath, they trigger a massive cache create penalty, forcing the system to reread thousands of words from scratch without giving you any warning. To avoid burning through your usage limits, you have to adopt a defensive prompting strategy, specifically designing your workflow to protect the cache. First is strict clock management. If your session sits idle past its time to live limit, don't just type another message. Instead, ask the AI for a concise handoff summary of where you left off, clear the chat completely, and paste that summary into a fresh session. Second is the data hierarchy rule. When working with massive reference texts, upload them into a dedicated project environment rather than dropping them directly into a live chat window. The project layer is optimized to hold those heavy documents efficiently. Third is the consistency rule. Once you begin a specific task, commit to a single AI model. Toggling your settings halfway through guarantees a total cache reset. Mastering these tools requires moving beyond casual chatting to actively managing the AI's memory state, protecting your session limits by ensuring the system only processes what is strictly necessary.